G'day everyone. So today we're going to have a look at example 1.38 to start off today. So we've got sort of a few lines here, and you could see that they create a triangle, okay, with a perpendicular height there. That might come involved at some point. Now they've given one length over here with 13 units, which also might come in handy. Let's see what the question asks. The diagram shows the points A, -2, 0. Okay, you can see there, B, 3, 5 at the top, and the point C, which lies on the x-axis. The point D also lies on the x-axis such that BD is perpendicular to AC. Okay, so the first thing that we need to ask ourselves is all that information there? And it is, which is good. Very helpful. Now, let's have a look at question A. So show that the gradient of AB is 1. Okay, so we can do that simply by doing our gradient formula. M of AB, okay, would equal to y2 minus y1. Okay, so 5 minus 0 over 3 minus 2. Okay, and yeah, that's 5 on 5, which is 1 as required. Okay, question B. Find the equation of the line AB. Oh, okay, so we can use our gradient now and just one of the points into the equation. Y minus y1 is equal to m bracket x minus x1. Very good. So which point do we think would be better here? Probably point A, -2 and 0. So y minus 0 is equal to 1 bracket, because that was the gradient of the line, x minus -2. Okay, so that works out to be y equals x plus 2. All right, cool. Next one. So what is the size of angle BAC? All right, trigonometry. We're looking at BAC. Trying to find that out there. So, fantastic. So we're going to be looking at this triangle there. Just redraw this. Okay. So I've got my right angle there. Okay, A, B. In this case, this will be D. Now, the bottom length here, okay, that's D not O, will be -2 to 3. Okay, you can look at the x's there. So -2 to 3. So that's going to have a side length of 5. And then on the vertical, this here, well, the y is 0 and 5, so that's also going to be 5. Now, you could have actually guessed that from what was given in the gradient before. Okay, so here our angle will be theta. So I've got question C. All right, so here I've got tan, I've got opposite over here and adjacent here. So I'll have tan theta is equal to 5 on 5, which is 1. So theta is equal to the inverse of tan 5 on 5. When we put this in our calculator, I'm going to go shift tan 5 on 5 at 45 degrees. Of BC is 13 units. Okay, we can see this up here. The length of DC. Okay, so we're going to find this here. Well, that's just simple Pythagoras' theorem, because we know that this length here is 5. Okay, and it is given as a right angle triangle. So question D. Okay, so I'll have, you could say that you have BD squared plus CD squared would equal to BC squared. D would equal to the square root of that. Now we're only taking the positive solution because we're talking in measurement, so we'll get CD is equal to 12 units. All right, fantastic. And that makes sense because it is less than the 13 given up here. And also, a lot of you might remember 5, 12, and 13 as a Pythagorean triad. It's a very common one. All right, so calculate the area of triangle ABC. Well, often these very last questions in these miscellaneous examples, they will use all the information from what you've calculated. So let's just put what we found previously in the top up here. So in this very last one, we had BC was 13, and then in that we actually found that DC here, okay, was actually 12 units. Here that the height was 5 units, okay. So overall, okay, I just need to times the base times the height, okay, and then half it. So overall, this will be 12 plus 5, which would be 15. Okay, so I'll have the area of the triangle is a half times, so we got BD, which is 5, BD, multiplied by AC, okay, so that's equal to a half times 5 times 17. Fantastic. So on would be 85 on 2 units squared. Fantastic. All right, so check your answers and see how you went.